Good day everyone. Now, we are going to discuss the different patterns in nature. Let us define first what are those different patterns in nature. Those four different patterns in nature are symmetry, fractals, spiral, and chaos. These different patterns in nature are what we call the different regularities of form found in natural world. First is the symmetry. Do you know what is symmetry? Okay, when we say symmetry, it is an exact correspondence of form and constituent configuration on opposite sides of a dividing line or plane or about a center or an axis. Things that remains unchanged after rotation or scaling are what we call symmetry. There are many types of symmetry. First is the reflection symmetry. It is often known as mirror symmetry or line symmetry. The reflection symmetry are often seen when an object is splitted into two but remains unchanged. It is also called bilateral symmetry. The example of this kind of symmetry are butterfly, mountain, cone, and car. Second is the rotational symmetry. This symmetry are those things that the parts are consistently aligned to its central axis. The appearance of these objects never change after a certain amount of rotation. The examples of this symmetry are the flower, the half lemon, the starfish, and LSC. Third is the translational symmetry. This type of symmetry is demonstrated by objects that do not change their size and shape even though they move to another place. The example of this symmetry are the repeating tiles, scale of the fish, and sequence. Fractals. Fractals are persistent patterns which are self-similar across different scales. This means that zooming in the lens onto the object's digital image does not provide a specific of a new view, but just the same as the original image. The examples of this pattern are fern leaf and lungs. Spirals. Spirals are curved patterns rendered around a central point by series of circular shape. The examples are the satellite image of a hurricane and shell of a snail. The last pattern is the chaos. Chaotic patterns are basic patterns generated from underlying complicated behavior. Chaos reveals the underlying patterns, continuous feedback loops, repetition, self-similarity, fractals, self-organization, and programming dependency at the initial stage. The examples are the clouds. There are also different shapes in nature. The crystal, rock formation, and animal kingdom. Mathematics makes our lives orderly and prevent chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem-solving ability, and even effective communicating skill. The example of golden ratio is the shell of a snail. The Fibonacci sequence can also be seen in this shell. Mathematics have benefits on human behavior. Mathematics can be used as language to communicate. That's the reason why mathematics is important in human behavior. The different symbols and languages. What is mathematical language and its importance? The ability to effectively communicate through the language of mathematics requires mathematical understanding. It is important in order to express our thought. It is used in communicate. The mathematical symbols are first are the plus or the plus symbol. It is commonly used in operation of addition. It is a process of increasing amount or numbers. For example, 10 added by 8 is equal to 18, or 10 plus 8 equals 18. There are also another keyword for this operation such as more than, the sum of, the total of, increased by. Subtraction. The subtraction is known as the operation or process of decreasing a number or amount. It is used when someone wants to minimize something. The symbol being used in this language is plus or minus. For example, 20 minus 7 equals 13. There are also another keyword for this operation such as less than, the difference of, less, decreased by, subtracted from. Multiplication. The multiplication is called the repeated addition of a number. For example, 2 times 6 equals 12, or 2 multiplied by 6 is equal to 12. There are also another keyword for this operation such as the product of, twice or double, thrice or triple of. Division. The division is a method of distributing a group of things into equal parts. The symbol being used in this operation is divide or slash. For example, 50 divided by 10 equals 5. The other term for these operations are the quotient of, the ratio of, or per. The different ways to solve problems that we tackled on the past unit are the inductive reasoning, deductive reasoning, and the Polya's strategy in solving a problem. The inductive reasoning. It is the type of reasoning that comes up to a conclusion by examining specific examples. A conclusion that is made by applying inductive reasoning is called a conjecture. Conjectures may or may not be correct. In this way of solving, the addition is always used. Example: what is the next number on the list? We should examine the list by knowing the sum of previous and preceding number. The answer is 21. The deductive reasoning. Deductive reasoning is unlike inductive reasoning. The deductive reasoning is a valid form used in proving observations and arriving at conclusions. It is a process by which one makes conclusions based on previously accepted general assumptions, procedures, and principles. Example: all triangles have three interior angles that sum to 180 degrees. Right triangles have exactly one 90 degrees angle and two angles that add to 90 degrees. Therefore, the two remaining angles of all right triangles that each be active. There are problem-solving technique created by George Polya. In using this technique, you should follow the four steps. First, understand the problem. Second, devise a plan. Third, carry out the plan. And fourth, review the solution. This is the example problem. Following the pattern shown in the number sequence, what is the missing number? In solving this kind of problem, we should first understand the problem. The problem aims to know the missing number to the sequence. Second, we should devise a plan. We are going to know the cube of the odd numbers from 1 to 15. Third, we should carry out problem. In carrying out the problem, we should know the cube of the odd numbers from 1 to 15. The sixth odd number is 11, so the answer is 1331. Last, we should review the solution. The answer is identified by knowing the cube of odd numbers from 1 to 15. In order to know the cube, the number should be multiplied thrice to itself. That's all. Thank you.